If something is a factor of another number, if you divide by that factor, won't we get a remainder of 0? We all know that 4 is a factor of 28, right? Because 28 divided by 4 equals 0. So the factor theorem says the binomial x minus a is a factor of the polynomial if and only if the output equals 0. The remainder equals 0. So let's look at our first example. To show that x plus 5 is a factor, hang on. Okay, I think I'm ready to go now. I don't know what that was, a little glitch. To show that x plus 5 is a factor of x cubed plus 2x squared minus 13x plus 10, first set x plus 5 equal to 0. So x equals negative 5. Place negative 5 into our synthetic division box, half box there. 1, 2, negative 13, and 10. And because I'm told that this is a factor, my remainder should be 0. Multiply, add, multiply, add. And there you have it. Remainder is 0. So, ladies and gentlemen, input negative 5, output 0. Y equals 0, x equals negative 5. So this is technically a root of the polynomial. It's where one of the places where our polynomial crosses the x-axis because y is 0. Okay, let's take our quotient down here, which is our answer, and put our variables back in. We began with a third degree polynomial, and we divided out one of those x's. So our answer should be 1x squared minus 3x plus 2. Now, this problem is asking me to find the remaining factors. So let's take our polynomial, and I'm going to go ahead and ask you to set it equal to 0 and factor it. FOIL factoring. So first times first equals first. Now class, can you give me two numbers that multiply to equal 2 and add to equal negative 3?
Negative 2 and negative 1.
So there you have it. There are your remaining factors. Algebra 2 students, can we go ahead and set these factors equal to 0 and find the two remaining roots? It doesn't ask us to do that, but that would be very simple to do. So I began with a third degree polynomial. I was given one factor. I divided out that one factor and was able to use the quotient to find the remaining two factors. Go ahead. You can finish the first page if you want, or you can go ahead and just work these last 8 problems following this same example. They're going to all look very familiar, very similar.